5 says sketch the graph of y equals x cubed minus 4x squared plus 4x. And I want to start using a few of the techniques that we've been investigating already in section 3.2. First thing, notice this is a factorable expression, so y equals x parentheses x squared minus 4x plus 4. If you take a common factor of x out. And then we have a quadratic trinomial. Notice that -2 and -2 would be the magic pair here, that both multiply to make the constant and add to make the linear term. They're exactly the same, so I could write x minus 2, but a better form here is going to be x minus 2, the quantity squared. Okay, so we can use the even and odd powers of x minus c theorem, our wonderfully named theorem that we like. All right. So what I can see here is the roots of this function are going to be x equals 0, where it's going to be a cross, and x equals 2, which is going to be a touch and turn. Just based on that theorem, I immediately know what the zeros are, what the roots are. So 0, 0, and 2, 0 are going to be 2 points on my curve, the x-intercepts. 0, 0 happens to be the y-intercept also. That's just a bonus. Y-intercept's one of those things you want to find because it's easy to find. Let x equal 0. You know, 0 minus 0 plus 0 equals 0, so it's pretty easy to find. But again, I can identify those 2 points, and I know the graph's going to cross through this one, it's going to touch and turn that one. Also, the fact that this is an odd power, the highest power term is an odd power, and the lead coefficient's positive, tells me left, down, and right, up. So with no other knowledge of anything, I know the graph. I'm going to just give you a quick sketch here. It's not going to be perfect, but I'm going to know it goes up and does something along those lines. Before I do anything else, I already know that because it starts low, left, down, right, up. It's going to cross through 0, 0. It's going to touch and turn at 2, 0. So it's going to look kind of like that. I didn't get specific points yet except for these two. But again, just with the things we learned in 3.2 day 1, we got a lot of good information out of that. All right? Next thing I'm going to do is I'm going to find more points. That's how you get a better graph. The more points you get, the better graph you get. The points I will pick, based on this knowledge, one thing I'd want to know is how quickly does it go down, how quickly does it go up, and how high does it go between here. That's the information I want to get from this. Okay? So what I would pick probably would be -2, -1, +1, +3, +4. Pick those 5 numbers. Oh, I didn't say 5, did I? We've already got 0 and 2 figured out, so I have to put those in my chart. Right? If I go to my calculator here, I'm evaluating the same function for multiple numbers. That's the easiest place to go. Y equals, and our function is x cubed minus 4x squared. Be careful with x cubed that you touch to the right to get out of the power level. That's 4x. Having issues with that myself right now. Keep a bunch of stuff in that power thing. 1, 3, 4. So we get -32, -9. 1, 3, and 16. I can't fit all those on there, okay? What I could do though is maybe use a scale. If I wanted to get all those points on there, if I put y at a 4 scale, keeping x at a 1 scale, it doesn't affect where the zeros are, right? So that's fine. I'm keeping x at 1 scale. If I wanted to modify x's scale, I'd have to do that now, and I have to rearrange these points. So if let's say x is 0.5, 2 is here now. If x is 2, 2 is there now. So just be careful of that. But if you're going to modify a scale, if you're going to make anything scale, make sure you show me the scale on both of them. A 1 scale means what normally is. Each dash represents 1. Now we got 4, 8, 12, 16, and 20 like that going up. -4, 8, 12, 16, 20, and so on going down. So -2, 2, 4, 6, 8, 10, or sorry, 4, 8, 12, 16, 20, 24, 28, 32 would be here. -1, -9, 4, 8, 9 would be about here. 1, 1 would be 1, 1. Wow. And then 3, 3, and 4, 16. Okay, so it goes up. kind of goes up a little bit there, and then it's going to touch and turn and go up there, right? So it's still getting us what we expected to see, but notice it's not quite as high up, like I drew it a little higher up there, but it actually goes up to 1. So had it been a 1 scale, it would have gone to there. So the other thing you might want to consider is this isn't necessarily the highest point in that area, so maybe you want to pick 0.5 and 1.5. The calculator is evaluating for us, so it's not that hard to do extra points. 0.5, 1.5. See if there's a lot of discrepancy here. 1.125, that's a little higher, right? And then 0.375, of course, lower. So at 0.5 is actually a smidge higher. So maybe it hits its high point kind of in here instead of right there. And 0.375 would be almost 0. So you kind of get a better feel for how it goes. It kind of hits its high point right around here instead of at 1. So it's going to go up. About like that. Now, it's real easy to check a graph. You're trying to sketch a graph, right? Because we have a calculator, and it can graph things for us. But again, I want you to do this using the calculator, of course, with the table, but not to graph it, just to copy what the graph does for you. But if you take a look at my dimensions here, this is 32, 36, 44. It goes down to negative 44, it goes up to 20, right? So let me set a window here. Y first went from negative 44 up to 20. We used a 4 scale. And then the x min and max negative 2 up to 4 with a 1 scale. Hit graph, and we should see our graph. Now, notice it doesn't look exactly the same because it's skewed. Here, our rectangle's a lot taller than it is wide. That one's more wide than it is tall, right? So you got to account for that, all right? But if you just take a look over here at the highlights of it, it hit a high point right around here, touch and turn there, crossed at 0, 0, right? Right. What I can do is I can finagle this a little bit so it's the same. Takes a little bit of doing. Need to get the scale kind of the same here, getting closer. That's pretty close. I want my dashes to be in the same spot. That's pretty good there. All right, we found 1, 2, 3, 4, 5, 6, 7, 8, 9 points. We had a little bit of information about crossing, touching, turning. We got a really, really accurate sketch of the graph without a whole lot of information. That's the whole idea here. We want to get the most efficient technique to get us the most accurate graph possible. That does a pretty good job of it, and it's not super hard to do. Again, it does involve some factoring, algebra skills. This theorem about touching and turning and crossing, the left down, right up, that theorem involving the lead coefficient and the sine power and stuff like that, to get us a pretty decent sketch of a graph without a whole lot of information.